continuity implies differentiability. We have proved differentiability implies continuity. Now we will see if a function is continuous, is it differentiable at that point or not. So we have example, f of x is equal to mod of x. This function is continuous everywhere, and determine whether it is differentiable. So we know that this function is continuous everywhere. For any value of x, this function is continuous. There is no discontinuity. Okay, but at x is equal to 0, the derivative of the function is undefined, and we prove that this function at x is equal to 0, the derivative of the function is undefined. The derivative of the function is not exist at x is equal to 0. Undefined at x is equal to 0. So we know the definition of the derivative, that is f prime of x is equal to, as limit h approaches to as h approaches to 0, f of x plus h minus f of x divided by h. We apply this definition on a given function and we simplify this, and we know that the mod of x is equal to under root of x square, and we apply this on this expression and we get this one, and simplify this expression by multiplying and dividing by this one, and after simplification we get this expression, and that is equal to a derivative of the function, that is x divided by mod of x. So this is the derivative of f of x, and that is x divided by mod of x, and if we put x is equal to 0, and the function, the derivative of the function will be undefined, 0 by 0. This is the undefined form. Okay, now we also prove this one by another by using other definition of a derivative. Okay, and or we apply this one and this definition of the function f prime of a as limit x approaches to a, f of x divided by f of a. We applies this definition on a given function, and we get this expression as x approaches to 0, mod of x divided by x, and when we apply left limit and right limit on this function, we get a different value, that is -1 and +1. This is the left hand limit and this is the right hand limit. Okay, right hand limit, both are not equal. Limit as x approaches to -0 of f of x is not equal to the limit as x approaches to +0 of f of x. Okay, so this means the slope of the tangent line will different for x less than 1 and for x greater than x less than 0 and for x greater than 0. Here we can see the slope of the tangent line. This is the slope. We know that the derivative of the function is equal to the slope of the tangent line. Slope of the tangent line. Now fail to differentiable at 0, this function f of x is equal to mod of x is fail to differentiable at x is equal to 0 because the limit of the slope of the tangent line on the left and right were not same. Visually, this result in a sharp corner on the graph of the function at 0. Here we can see that at x is equal to 0 we have a sharp corner. From this we conclude that in order to differentiable at a point a function must be smooth. At that point there should not be any sharp corner in the function. Okay, so we see this with the help of graph. We will see at x is equal to 0 the function is not differentiable. So here we can see that the function has a derivative when x is less than 0. When x is equal to 0, the function will be undefined. At that point the derivative of the function will be undefined. Here we can see that At that point the function have a non-derivative that is undefined, and when x is greater than 0 the function has a derivative. So now we have a Matlab code to plot a function, and this is the Matlab code to plot a function that we have discussed. Let us consider some additional situation in which a continuous function failed to be differentiable. Example: consider the function f of x that is equal to cube root of x, and we apply this definition on a given function, and we find the derivative of the function at a point. Okay, so we apply the definition of this function uh, on this function at x is equal to 0, and we get this expression. And after simplification we simplify this function by multiplying and dividing by this one, and we get this expression as the limit x approaches to 0, 1 divided by cube root of x square, that is equal to positive infinity due to of x square. So at x is equal to 0 the function is not differentiable. The derivative, this mean and the slope of the tangent line at x is equal to 0, that is infinite. Okay, so when the function have a tangent line with infinite slope, at that point the function is not a differentiable. So this is the function, this is the graph of the given function that is continuous everywhere. F of x is equal to cube root of x, and at x is equal to 0 the function has a tangent line with the slope infinite slope. This means at that point the function is not differentiable. So the function is continuous at 0 but not differentiable at 0. This means if a function is continuous, it does not imply the differentiability. It doesn't mean if a function is continuous it will also be differentiable at that point. Okay, at x is equal to 0 the function has a tangent line with infinite slope, and we can see if the x is increasing, the slope of the tangent line will also decrease. At x is equal to 0 the function has an infinite slope, but as x is increasing the slope of the tangent line is also decreasing. Let us consider another example, and we will see uh, is continuity implies a differentiability or not. So we have example, consider the function that is f of x is equal to this one if x is not equal to 0, and 0 if x is equal to 0. Also has a derivative that exhibits interesting behavior at 0. So solution, this is the definition of the derivative. We apply the definition of the derivative on this function, and we will see that if a function is if a function is continuous, then is it differentiable or not. So we apply this definition on this function, and we have a is equal to 0, and we get this expression, and the derivative of the function at 0. Okay, so limit as x approaches to 0 sine of 1 divided by x, as we will see the behavior of the function when as x approaches to 0. So this limit does not exist essentially because when we substitute x is equal to 0 we will get infinity. So essentially because the slope of the secant line continuously changes direction as they approaches to 0. So we see in the behavior of the tangent line, behavior of the slope of the secant line as the limit is approaches to 0 with the help of a graph. And this is the graph of a given function. This is of this function f of x, and we will plot a secant line, okay, between 2 points on, and we will see the slope of this secant line will changes continuously with positive and negative as x approaches to 0. So this is the graph of a given function, and now we see the secant line, and this is the secant line, and we see the slope of the secant line changes continuously as x approaches to 0. As x approaches to 0, the slope of the secant line is continuously changes. So this means the function is not differentiable at 0. Three conditions for when a function does not have a derivative. If a function is not continuous, it cannot be differentiable, since every differentiable function must be continuous. However, if a function is continuous, it may still fail to be differentiable. F of x is equal to mod of x fail to differentiable at x is equal to 0 because the limit of the slope of a tangent line on the left and right were not same. We have already proved with the help of example. When we find the derivative of this function, and when we execute limit, we get as x approaches to -0, the slope of the tangent line was negative, and when x approaches to +0, the slope of the tangent line was positive. For x less than 0, for x greater than 0, and because of this one, the function is not differentiable at x is equal to 0. So visually this resulted in a sharp corner on the graph of the function at x is equal to 0. We can see that this is the graph of this function, and this is the graph of this function, and x is equal to 0, we have a sharp corner, and for this we have to conclude that in order to differentiable at a point, a function must be smooth at a point. Now we have a next condition for f of x is equal to cube root of x. Here this is not a square. A function is failed to differentiable at a point where there is a vertical line. We have also already proved this with the help of example. When a function have a tangent line with vertical slope with infinite slope, or a vertical tangent line, at that point the function is not differentiable, and at x is equal to 0, this function has a vertical tangent line with infinite slope. So at this point the function is not differentiable, and this is the second condition. And now we have a third condition, and this is the function. A function may fail to differentiable at a point, more complicated as well. We have also proved this one with the help of example, and we also plot of graph of this function. When the function continuously changes slope of the secant line, this means the function is also not differentiable at that point. And this is the graph of this function, and we can see that the slope of the secant line continuously changes as x approaches to 0. So as we can see that as x approaches to 0, the slope of the secant line